Hello all, welcome to this online recording sessions in data science. So in this Python session, we are dealing with OOPS concept, right? So what are there in OOPS concept? We have seen previously also, right? So let us recap what we have discussed so far, okay? So why we need OOPS? So integrate real world into virtuality, okay? So in real world, some things are happening, okay? So some actions are taking place, some activities are happening, right? So if you want to integrate all those things into programming part, okay? So if you want to bring all those activities and the involvements of surroundings of what you have into programming part, so what we need? OOPS concept, okay? So integrating the real life into virtual life, okay? So that can be possible with the OOPS concept, okay? Class, we have these concepts, okay? Class, object, okay? Okay, so in this class we have attributes and methods. So all this we have discussed previously. Let us recap, okay? So what is class? Blueprint for creating object, okay? So it is a blueprint for object, okay? So let us say, suppose constructing a house is my class, okay? Then what are the objects? I'm telling blueprint for creating objects, right? So windows, doors, halls, all those things are objects, okay? So all those blueprints of those objects like windows, doors, curtains, okay, halls, all those things together combine a house. So house is a class. So all the halls, doors, windows and all the objects, okay? So if you now tell me, so if I combine all the objects only, I'm getting a class, right? Okay, so blueprint for creating objects, okay? So instance of a class means, say suppose I have a bikes, okay? So bike, so if I pick some random bike, it may be any bike, right? Okay, from the set of bikes, okay? So that is what you can take a real life example for object, an instance of a class, okay? So if you pick any bike, so that will be an instance of that class, okay? Okay, that will be all related to the class, okay? So this class can consist of attributes, nothing but variables, and it also consists of methods or functions, okay? So this is all we have done so far. Yeah, inheritance also we have discussed. So in Python generally we have four concepts of four topics in inheritance, okay? Single inheritance, we are just recapping, okay? Single inheritance, multi-level inheritance, multiple inheritance, hierarchical inheritance, okay? So these four types we have in inheritance part, but mostly the first three are used mostly in Python, okay? So single inheritance looks like this, right? So A, B, okay? So A, B. So A is a base class. This is a derived class, okay? A can be also called parent class. B can be also called child class. All these are names, okay? Base class, derived class, parent class, child class, main class, okay? We can also call main class. We can also call B as subclass, okay? So all these are terminologies, okay? So if I am calling A as base class, then I need to call B as derived class, okay? It is better to call like that, okay? So if I am calling A as parent class, B as I need to call child class, main class, subclass or child class, okay? So these are the terminologies that are used to describe parent and child classes, okay? So single inheritance looks like this, only parent and child, okay? So child can inherit all parent properties, okay? Next, multi-level. So multi-level inheritance, it is in levels, okay? 2, 3, okay? So this is A, B, C. This may be considered as a grandparent. This may be considered as a parent. This may be considered as a child. Okay. So here we'll have a order wise. Okay. In multi-level, it will be in levels. Level 1, level 2, level 3, like that. Okay. So now you tell me, parent can inherit grandparent characteristics. Okay. So parent is derived from grandparent. Child is derived from parent. Okay. This is multi-level. Multi-level inheritance. This is single inheritance. Okay. Single inheritance. So next, third one is multiple inheritance. So multiple inheritance, what do you have? We have multiple parents. Okay. So from this multiple parents, we have one derived class. Okay. So A, B. So this can be considered as father, mother, child. Okay. Now you can tell me, so child can inherit both father characteristics and mother characteristics. Okay. So but you can tell like this also, father cannot inherit mother characteristics, mother cannot inherit father characteristics, but both of these characteristics are inherited by child. Okay. So that you can remember in multiple inheritance. This is multi-level inheritance. Next, fourth one will be hierarchical inheritance. Hierarchical inheritance. So we have one parent and two childs. Okay. A, B, C. Okay. This can be child 1. This can be child 2. So this is parent. Okay. So in hierarchical, we'll have like this. Okay. So these structural diagrams may be helpful for when you are implementing the coding part. Okay. So when you are implementing coding part, so you need to mention, you need to inherit A into B. C can inherit A. Okay. So you can look into this. Okay. In a block diagram, it is easy to remember. Okay. So this we have done it. So we will be also recapping the code. Okay. Okay. So this helps in reusability of the code. Inheritance helps in reusability of the code. Next, abstraction. What is abstraction? Hiding the implementation part. Okay. See, suppose if I have a mouse. Okay. So I have a mouse. So what I am hiding all the complexity. So what is all inside it? I am hiding it. Just if you see, you can see only the visible part, how good it is, right? But internally you see how it is made and all, that is all hidden, right? Okay. So abstraction is all about hiding the implementation part. Okay. So or hiding the complexity. Okay. Hiding the complexity and show only essential ones. Okay. So inside it may be all the parts, but we'll be hiding it. We'll be showing only the what is essential. Okay. Okay. That is what abstraction, hiding the complexity or showing the only essential. Next, polymorphism. Okay. Poly means many. Okay. So we are defining functions or methods in class, right? So same function performing many tasks. Okay. So this in polymorphism, we again have overloading and overriding. Overriding concept. Okay. What is in overloading also we have another sub two topics. Okay. One is operator overloading. The other one is method overloading. Okay. We have two subparts in overloading. Okay. Polymorphism has two concepts. Okay. Overloading and overriding. So in overloading we have operators, operator overloading and method overloading. Next one is overriding. Overriding is we will define one method. Same method I can define. Okay. In that case what happens? One method will be overridden with another method. Okay. So if I declared a method, okay, def let us say method 1. Okay. So in this I have defined some statements. Okay. Print. Okay. So class. So in class we will define all this. Okay. So class. Okay, so in class we'll define method. Okay, so after deriving this class in class B. Okay, so after deriving this class in class B, so here what we will do, we will define again same method here. Okay, same method here. So in this case what happens, if I declare, if I instantiate object or create an object for this class, okay, child class, what happens if I call one method 1, which method 1 will be called, this method 1 or this method 1? Obviously this method 1. Okay, this method 1 will be overridden by the previous one. Okay, that is what overriding. Okay, many forms. So you can see example, real life example, chameleon. Okay, so this chameleon only appears in different colors. If it is in land, it may be color with land. Okay, it may be on, if it is on trees, it will create itself like a color. Okay, tree color. Okay, so same color, same animal creating different colors according to the surroundings, right? So similarly, so whatever the methods that we are using inside the class, those will be also appearing to be like that. Okay, they will be behaving like a different according to situation. That concept is called polymorphism. Okay, next, encapsulation. I can give example like capsules, how the capsule looks, capsule tablet like this, right? So in this capsule we have one drug. Okay, so if you remove this capsule, we find one drug inside it, right? So that means what, we are storing the drug inside it. Okay, drug inside the capsule. Okay, so how you can define this? Okay, hides the implementation details. Okay, hide the internal or implementation details. Okay, there is a little bit difference between encapsulation and abstraction. You can see it here. Okay, so abstraction is hiding the implementation part. Okay, but encapsulation is protecting the data. Okay, protecting the data. This is protecting, abstraction is hiding. Okay, so how you can do encapsulation means we have access modifiers. So with this access modifiers, we will able to perform encapsulation. Okay, encapsulation. So what are these access modifiers? These are again 3: public, private, protected. Okay, so how does public looks? So if you generally define a variable inside a class, okay, that is called public. By default, whatever the variables that we are creating, those are all called public. They can be accessed inside the class and outside the class. Fine. Okay, what are private variables? How we need to declare private variables? Okay, we can declare private variables by defining double underscore. Okay, so if I'm declaring a variable, so I can put double underscore before that variable. Okay, so for method also, so if I'm defining one method def, so I can put double underscore method 1. Okay, so this is, what is this? Private method. I can call, if double underscore is present before method name, then I call that is as private method. Okay, if double underscore is present before variable, then I call that is as private variable. Okay, how we need to declare protected? So protected can be declared with the single underscore. Okay, so now when can be public variable where it is accessible, private variable where it is accessible, protected variable where it is accessible? Let me share that. Okay, public variable or method accessed everywhere. Okay, outside the class, inside the class. Okay, private variable can be accessed inside the class and derived class. Okay, derived class can also has accessibility of this private. Okay, protected. So protected variable or protected method can be accessed only inside the particular, okay, particular method, okay, wherever it is, wherever it is, wherever the class has protected variable or protected method, in that class only we are able to access this protected variable or method. So I can write accessible only to particular class, okay. Private is accessible to particular class as well as derived class also, but protected is accessible only to particular class, okay. Okay, so this is binding the data, okay. So binding the data is encapsulation, okay. So we can implement using this access modifiers, okay. So we can have a recap of all this, okay. So let us see all these concepts with the help of code part, okay. So now let us move to coding part of this OOPS concept, okay. Okay, so I think we have stopped here, right? Inheritance part, okay. So let me show, just recap the inheritance part also. In single inheritance, what is happening? We have two, parent and child, right? So this is parent and this is child, okay. So child can access child class, okay. So this is parent class, okay. So child can access parent class, okay. So now if I create object for child class, okay, so if I create object for B, okay, we can access methods present in A as well as present in B, okay. Let us see it, let us run this. Yeah, so now if I take a code cell, so B1 dot, so B1 is the object for child class, A1 is the object for parent class. So if I want to access B1 dot, so here you can see which are the highlighted ones, those we can access it, okay. Okay, I can take method 2, method 1, okay, whatever I want. So see, I am accessing parent method, okay, whatever it is present in parent class. So if I want to access, so B1 dot, see again it is showing what are the accessible methods from the above inheritance. You can see all this, so you can select any of this method which are accessible, okay. So this is very advantages of the AI that is integrated in the Google Colab. Yeah, this is method 4. This method 4 is present in child class, method 1 is present in the parent class. So this is single inheritance. So multiple inheritance. So multiple inheritance, what is happening? So we have multiple levels, okay, multiple levels. So this is like a grandparent, okay, like a grandparent, okay. So this class is like a parent, okay, parent class, okay, parent class. Imagine like that. So whenever you're calling, you shouldn't tell grandparent class or parent class. You can take that example to describe this, okay. Multiple level, okay, level is there. So it will be in levels, level 1, level 2, level 3, like that. So last one will be the child class, okay, child class, okay. Okay, see, grandparent is inheriting, so sorry, parent is inheriting grandparent, okay. So A is getting inherited here. So similarly, child is inheriting parent, but it cannot inherit grandparent, right? So in that way you can understand this concept, okay. So how many objects I need to create to access all the methods that are present in all the classes? I need to create 2 objects minimum, okay. I need to create object for parent to access parent methods as well as grandparent methods, Okay, if I create object for this. Okay, so if I create object for child, I can access child methods as well as parent methods, but not grandparent. That you need to remember. Okay, so this child can access only parent but not grandparent. Okay, I can inherit my parent characteristics, not grandparent characteristics. My grandparent characteristics are inherited by my parents. Okay, not by me. Okay, like that you can understand. So you can define, you can declare objects. A1 is for class A, B1 is for class B. So you can try to access it. Okay, so A1 dot. So A1 dot means what it is showing? Method 1 and method 2 only. These are present in class A only. Okay, so that's why it is showing 2 only. So if I invoke B1 dot, then see how many methods I am able to see. So out of all these methods, you can access it. Method 1, method 2 are present in class A, 3 and 4 are present in parent class. Okay. So simply if you are trying to start writing the code, AI will help you. Okay. C1 dot, if I am taking, see, all the methods I am able to all the methods I am able to take into consider. Okay. What? I'm able to access grandparent also. Yes, it is possible here. Okay. Sorry. Okay. You can check it. So grandparent methods are also accessible here. Okay. You can check it. Okay. C1 dot. C1 is the object for child class. Okay. So whatever that are highlighted here, you can access all those methods. Okay. C1 dot. You can access all the methods. Okay. If I create for object for child class. Okay. Okay. Next, multiple inheritance. In multiple inheritance, what happens? We have mother, father, and we have a child. Okay. So mother cannot inherit father characteristics. So this is like a father. Okay. Father class. This is like a mother class. Mother class. Okay. And this is like a child class. Okay. So child can inherit both mother and father. Okay. You can see here. But mother is not inheriting father. Father is not inheriting mother. They are independent or separated. Okay. So you create objects. Okay. You create object for C. Then you are able to access. Okay. A and B have created, right? So C also let us create. Okay. C1 is equal to C. Okay. C1 equal to C. So if I am writing C1, let us see C1 dot. All the methods I am able to access. So in multiple and multi-level, for a child class is able to access all the methods. Okay. C1 dot. So if I am writing B1 dot, so I am able to access method 3 and method 4 that is present in B class only. Okay. So I cannot inherit father. Okay. Father characteristics. I can inherit only mother characteristics, whatever present in this side class. Similarly for A also. Okay. That is about multi-level. Okay. So similarly, hierarchical also you can consider. Why in hierarchical what happens? Okay. In hierarchical, it is like this. In hierarchical, we will be having somewhat like this. Hierarchical. Okay. So in a hierarchical, both parents characteristics can be inherited, but that is somewhat similar. Okay. Okay. Both characteristics here B can also inherit A. That is possible in hierarchical. Okay. Okay, so you can check it. Okay, so this is hierarchical inheritance. Okay, so hierarchical is least cases it used, but as of now you can remember those three. Okay, but try to see that hierarchical is also there. Okay. Okay, next polymorphism. What is polymorphism? We have two cases, right? In polymorphism, method overloading and method overriding. Yeah. Now I will introduce one new feature in Colab. Okay. So here generate with AI is there, no? You can click this. Okay. So in this you can give a prompt. Polymorphism. Okay. So if I'm giving polymorphism as a prompt, so see what is happening. Polymorphism in Python. Okay. So polymorphism in Python, if I'm giving a prompt, so my code is getting generated. Okay. This is one of the feature that you can use it. Okay. If you want to learn the code. Okay. If you want to take the help of the code. Okay. So you can see here dog, cat are separate classes. Duck is also separate classes. Okay. So what I'm doing, I'm declaring object for the different three classes. Okay, duck, cat and dog. Okay, so now I am trying to call, okay, animal underscore speak. Okay, animal underscore speak. So I am calling this function. Okay, with the parameter. Okay. Okay, now you see, if you observe, same method name I'm calling with different parameters. Okay, this type of overloading is called method overloading. Okay, same method name with different parameters is called method overloading. Okay, so method overloading. Okay, this is example for method overloading. So I can run it, so you can see it. So if I call, I need to run this, right? So if I run this, what I'm getting, I remove this. Okay, so if you can remove this operator overloading, and I'm just trying to show you only the method overloading, what happens. Okay, so if I remove that, see, you can get the outputs like this. Okay, so that is present inside the all the classes. Okay, wolf, meow, quack. Okay, so these are present in different classes. You see, same name. Okay, same method name I'm calling with different parameters, then that is called as method overloading. Next, operator overloading. Operator overloading, what happens? Okay, so plus, if you take plus symbol will perform addition as well as it will add strings also. Okay, so if I ask AI separately for operator overloading, it will generate. Let us ask. So let us ask our AI, or we can operator overloading. Yeah, see, operator overloading, it is giving same example, right? Okay, so see here, so this is addition. So what is happening here? You can see two numbers are getting added. Okay, 2, 3. Okay, two numbers are getting added. So what output we are getting? Let us check that also. We are not getting any output. We are not defined anything, right? So if I, yeah, otherwise I can manually write the code. Okay, that example may not be appropriate for a beginner to learn operator overloading. So I'm just a equal to 10, b equal to 20. So print a plus b. Okay, print a plus b. Okay, so Yeah, print a plus b. Okay, I can remove this also. Yeah, that's why there may be some problem with AI also. It keeps on giving. This is also where sometimes disadvantages. Okay. Okay. So user need to check it. So yeah, see here in operator overloading, this plus symbol is adding two numbers. That means it is performing addition. Okay. What if I take strings? Okay. What if I take two strings? Okay. What happens in that case if I give a plus b? Okay. Programming. Okay. So now if I ask to print a plus b, what it is doing? It is not adding, it is concatenating. It is just joining if you see it here. So Python program, it is just adding, it is not performing addition. So here this plus symbol is acting as a concatenation. So previously the plus symbol is acting as a addition, now it is acting as a concatenation. So this is operator overloading. Okay, this is all about overloading concept. Okay, so now overriding. Okay, so now let us see what is overriding. Okay, so now let us ask the AI only. So what it will give? Okay, so if you just click this generate, it will give. Okay, what it will give? The code part. Okay, overriding. Okay, overriding means just I am giving overriding. Okay, as a prompt. So, yeah, see method overriding. This is the example for method overriding. So see now, I have a parent class, I have a child class which is inheriting parent class also. So now you see same method is defined in parent class, same method is defined in the child class. Okay, so now if I create object for this child class, okay, if I create object for this child class, okay, child is the object for child class, parent is the object for parent class. Okay, so what I am getting? Okay, what I am getting if I am asking to print child dot speak. Okay, child is the object, right? So child dot speak. So which method is invoking here, whether parent method or child method? You see, child method is getting invoked, right? This is a child method. Okay, so now if I invoke parent method with the help of parent method, this is a parent class. Now you see I am able to access parent class if I specifically called with that object only. Okay, but whereas when I call with the child object, what is happening? It is not calling parent, but it is calling child only. Okay, so indirectly what happens? So it is getting overridden. So this method is getting overridden with this method. Okay, okay, that is what overriding means. One method is overriding with another method. Okay, and you can see whenever we are asking to print the output, this will only be getting executed. Okay, if I call this with the child object. Okay, that you can see here. Okay, yeah, this is all about polymorphism. Okay, we have overloading and overriding and its types we have discussed, right? Next, encapsulation. What is encapsulation? Okay, how do we can generate encapsulation using access modifiers, right? Public, private, protected. So let us ask AI encapsulation. Okay, so it will define. Okay, yeah, so this is my class which is having a constructor. Okay, so here I am not having any method, or should I manually define? Okay, yeah, you see this, okay, so you see this method, this is public method because I have not declared any underscore before method name, here it is there. So when I'm discussing variable concept, I will declare how to name a function name, how to define a class name. We can use underscores also, right? But if you use underscore before method name, then that becomes a what? Private, right? So if I'm not using anything, then that becomes a public. Okay, so this is public method. Okay, so now you see I used underscore here before method name, so then this method name is called private method. Okay, if I use single underscore, if I use double underscore, okay, this is protected, or you can call really private method. Okay, so this all you can experiment using function calling. Okay, so what happens if I call public methods? Will they are accessible inside the class, outside the class? You need to see it. Okay, so outside the class also you defined with the same name, then try to access it. Okay, so in that case what is happening, we can check it. Okay, so for variables also you see, so this is private, so all the variables that are inside the constructor, okay, are called private ones. Okay, that means they are accessible only inside the class and derived class. Okay, so apart from that you can declare variables like this also, apart from constructor. Okay, so you can declare like this also, a equal to 10. Okay, so this is also a private, okay, private variable. Okay, this is also a private variable. Okay, this is also private variable. Really private means protected. Okay, okay, so now I am creating object for my class. Okay, so I am creating object for my class. Where is my class? Here. Okay, so for this class I am creating an object. Okay, so what I am trying to do, obj.public method. So I am trying to call this method. Okay, this is public, so it can be accessible inside the class, outside the class also. Okay, obj.public method. Okay, obj.get really private variable. So you can comment this one. Okay, run this. I'm really private. You see, really private, where it is, yeah, this method is getting invoked. Okay, so where this method is, only inside the class. Okay, only inside this class. Okay, this is returning. Okay, if you observe. Okay, so in this way we can experiment it. Okay, whether it is accessible in the derived class or parent class. Okay, outside the class and inside the class also you can experiment it. You create an object, try to access it from the parent class and the derived class, and you see it. Okay, so private methods and private variables are accessible inside the class and derived the class. Okay, public are accessible throughout anywhere. Okay, protected are accessible only inside that particular class. Okay, so this is only accessible only inside the class. Okay, but not outside the class. If you declare another class, there you cannot access it. Okay, in that way you can understand this concept. Okay, so now last method is there, right? What is the topic? Abstraction. Okay, for abstraction what we need to do, so we need to import one abstract ABC. Okay, abstract base class we need to import. Okay, we need to import this is abstraction. So in this abstraction, to implement abstraction, what we need to do, we need to import abstract ABC class. ABC is a abstract base class. ABC stands for abstract base class. So we need to import ABC variable and abstract method. Okay, we need to import all this to implement it. Okay, so I'm just mentioning it in the text format. Okay, so while I'm generating the code, you will see it. So I'm typing abstraction. Okay, so just remember, we need to import ABC variable and abstract method from the, we need to import these two parameters, then only we can create abstract method or abstract variable. Okay, abstraction is used for hiding the implementation part, right? Yeah, you see it here. Yeah, this is abstract method. So if you declare with @abstract method, this becomes abstract method. So if abstract method is present in the class, then that class will be called as abstract class. So this class is now abstract class. So you see the very first line, from ABC import ABC. Okay, so ABC is the abstract base class. Okay, so we need to add that while we are defining the class. This is a special case. Okay, when you are importing, when you are trying to implement the abstract, okay, abstraction. So for in the class name, we need to declare this ABC. Okay, abstract base class. Okay, then only abstraction can be possible for that class. Okay, so since abstract method is present inside this class, this class becomes abstract class since abstract method is present. Okay, so for every abstract class, we need to create concrete class. Okay, this is called as abstract class because having abstract method. Okay, so for every abstract class, we need to create concrete class. Okay, so concrete class. Okay, so we will be creating concrete class. Again, we will be redefining the abstract method in the concrete class. So that is must. Okay, concrete class needs redefining methods present in the abstract class. Okay, so we need to again redefine it. So abstraction means protection, right? We cannot see it. So if you want to see it, we need to redefine them in the concrete class. Redefine methods present in the abstract class. Okay, then only you can see it. Okay, so if you run it, see, you can see it. Okay, so if I'm not redefining it, if I directly call speak method, these all are the concrete classes. This is also one concrete class, this is also one concrete class. Okay, so I'm commenting this. Okay, or else I can remove all this. Okay, so I will be creating for a dog. Okay, so I'll be creating an object for dog. Okay, so dog. Okay, for dog we will be creating an object that the object name is also dog. So let me label it as dog. Okay, so I'm removing all this. Okay, I'm having only concrete class and only one concrete class and one sorry, animal, right? Okay, so A is equal to animal. Okay, okay, so if you are creating an object or else yeah, so remember that if you can take only one concrete class and one abstract class. Remember that you need to redefine them in the concrete class. So if you're not defining in the concrete class, then your methods will not be accessible. Okay, that you can remember it. Okay, now it will be accessible. If I remove this, all this will be accessible. Okay, I hope you understood, right? So what I'm trying to convey. Okay. Yeah. So that's all for today's topic. So I hope you got an overview of all the OOPS concept, right? So thank you for giving this opportunity.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.